Alright, this is my presentation on the final project for Data Science 4100, and I did my project on NFL fantasy scores and player performance. And the goal of my project was to build a predictive model for season-wide fantasy scores, which I wanted to make because, well, I play fantasy football, and I wanted to create something that I could use to pick players. And so first I outlined my whole entire process that I was going to use for the entire analytics process. First, I was going to collect my data, and the tool I used for that was the FF Analytics library, which made it really easy to pull in all different types of metrics for fantasy football data, and my exploration, cleaning, storage, visualization, and modeling, which we'll get to all of that. But first things first, the data collection. And I found this library, which is built by a team of people who are trying to, do sort of the same thing I'm doing. And it's a pretty easy tool to use. It's a custom web scraper built by a group of people, and it lets me pull in data from many different sources for fantasy football. I chose to just include the Yahoo Fantasy scores, mainly because I use Yahoo Fantasy Football, and I include the data for every single position: quarterback, running back, wide receiver, tight end, defensive and special teams. And yeah, that's basically the core of the data collection. And my next step was data exploration. And on first inspection of my data, after I pulled it in from the API, and it scraped all the data from the Yahoo databases or whatever, it was split by position, and what I wanted to do was combine that into one single data frame or data set with every single metric for each player, and that's what I did. So it has every single position put together. And next I visualized one of the variables, the pass attempts, and I discovered that there was a lot of players with just 0 for their pass attempts, even amongst quarterbacks, and that's just indicative of the fact that there's a lot of players that don't play. There's only a few subset of the many quarterbacks within the NFL get any playing time and thus log any pass attempts or any other statistics. And this was the case across every single position. And so next was my data cleaning step, which consisted mostly of treating these players with very little statistics or 0 as outliers, and I removed them from my data set, which let me see a fairly improved distribution of each of the variables. And one of the other steps of my data cleaning was converting this it's down here, my fantasy owned scores. They were string percentages, and I converted them into numbers so I can use them in the model. And next, my cleaning step was handling the NA values. And my solution was that I wanted to use, for every single player, I wanted them to have a value for whatever metric, no matter what position they were. So I wanted passers to have defensive numbers, even if it was 0. And so that's what I did, and I imputed all the data points that were NA with the mean value for whatever column pertaining to that specific statistic. So whether it was defensive sacks or pass attempts, if it was NA, then it was imputed with the mean value, and that was how I handled that. Next was data storage and retrieval, and this step was very simple. I used a SQLite database to store the data that I had so far. And then I retrieved it pretty easily with this one method. So yeah, I stored the data set that would eventually use my model within the database for SQLite. Next, I continue my exploration of the variables with my clean data, and I visualized all the distributions. A lot of these were discrete, with the exception of passers, which you can see is much more uniform here. This is just indicative of the fact that there were a lot more receivers, which made a much more continuous distribution. And what it turned out that a lot of these distributions, or a lot of these variables, ended up not contributing that much to the model and had to be eliminated. And we see that again later in the analysis. And next was my correlation and collinearity analysis. The challenge here was, and for my exploration in general, was I had a lot of variables. So I wanted a way to pack all of that into a concise visualization, and the solution for this was a parallelogram. Excuse my pronunciation. And we can see the relationships between all the variables in this clean plot, and this really helped visualize everything really well. I did split by position and over all this gigantic parallelogram, and from this I learned that between positions there weren't that many correlations. So you can see all this white space. That just means that passing metrics are related to passing metrics, and like defensive sacks wouldn't be related to pass yards in any way, and that makes sense that all these correlations are concentrated within their positions. And next was visualizing my independent variables to my dependent variable, which was the fantasy points predicted for that player, or actually logged by that player for the whole entire season. And this is the site points variable within my data set, and we can see that there were mostly positive relationships among all the variables, which with a very few exceptions, and there were also a lot of data points which had no clear relationships, and these ended up being thrown away later because I used the backward fitting strategy for my models, and again split by position. And finally, my last step was actually constructing my models. And for my initial model, I included every single in-game statistic for every single position, whether it was passing, rushing, defensive, whatever. And I used a backward fitting strategy. So I started with all my variables and for my initial model, and it performed very well. It had a very low mean squared error, which I used to evaluate my models. And yeah, after I took out the insignificant variables, it improved even more. As you can see with this initial mean squared error, it's around 7.8 or whatever, and it lowered to around 4.3. And yeah, there's a pretty high R squared value. And that's basically it.